Oh, hello. I didn't see you there. Welcome to the Sam Labs Summer Edition webinar. What we're going to talk about today is how we're going to use Sam Labs potentially in a summer setting. Maybe we're testing something out. Maybe we want to launch something. Maybe we want to just do an activity that shows us how we can use a brand new lesson plan that we're releasing at ISTE next week. So we're going to go through a number of things. We're going to look at lesson plans, brand new ones up on the website and available. 2, we're going to look at the all brand new classroom kit that we have here. 3, okay, there we go. Back at it, sorry, there was some sort of error message. Then we're going to look at a project specifically from age group 9 to 10 in which we're going to use computational thinking. We're going to use design thinking to build a smart doorbell, which is going to be the activity that can be used across a range of different things, whether it's a makerspace where you're prototyping and building and using design thinking to get to those steps and iterating, or whether it's in a classroom in which we're using different means from ELA to mathematics and also design and technology. And also, lastly, we're going to look at the brand new features that we have in terms of Blockly and the Chromebook online as well. So let me get right into it. I have, first of all, created a wonderful presentation to recap for those of you who do not know us. We are Sam Labs. So the key thing that we want to do is we want to empower teachers, you watching, with the most engaging STEAM solution of lesson plan, apps, and electronics. So really these 3 things together today we're going to look at. And our goal is really through that to inspire every student to discover the fun in coding and creating. So the company was founded in 2014 in the UK, and actually at that time there was a computing curriculum that was introduced to all schools in the UK, and teachers as low as grades 4 had to teach coding. So how did we actually help that solution? Well, we created that app, the electronics and the blocks and the lesson plans that help the educators teach the basics of logics and coding and really break down that scary word. So really helping educators. We've worked with a number of different groups in the past, working with Microsoft Education, but also really focusing now on progressing through to helping your needs. So we're going to look at some of the reasons why this is a fantastic use for your summer. We have the reason of why Sam Labs is beneficial is the reason that we need STEAM. Why do we need STEAM? So if you don't know, STEAM is science, technology, engineering, arts, and mathematics, just to refresh your memory. And it's crucial because as we move to 21st century skills, we realize that there's some skills lacking. First of all, 65% of all future jobs haven't even been invented yet. So how can we address those skills in the right time, in the classroom, in the summer camps, wherever you may be using STEAM to really build those foundations for the future? I recall when we were at school, we weren't really allowed to use social media, etc. But this turned out to be one of the largest employers of a whole generation. So really, there's a lot of information out there, and current solutions are pretty hard to adopt. So we're going to look at a very basic way of using that today. Really, we know that the skills will change and the demand will change. So our key focus is we're going to use computational thinking to develop this inventive mindset. And really what we're looking at today is a lesson plan that not just really relates and has NGSS standards, but also Common Core. So how does that really transfer the skills for students? So every activity that we're going to be doing is going to be transdisciplinary, as you will see in today's activities. And we're going to be focusing on 2 main things, decomposition and algorithms. So really we're going to look at how do we take something scary like coding and break it down to something really easy to understand. And then in terms of algorithms, we're just going to find a solution to a problem in different steps. So we're going to use those 2 things today. And really it's about moving away. We want to start using collaboration, computational thinking, creativity, and communication to really foster an inventive mindset. So if I go back here, I'm going to quickly stop sharing my screen. So you should see me again now. I just want to mention that in the classroom kit that we have here, inside of it, you find these little trays. And each one of these trays is easily distributed to a student in the class. Each person gets one, or potentially in group work, you decide. So within that kit, we're going to use a couple of pieces for our lesson plan. But first, let's get into the lesson plan. What is the potential project that we could build? So the first thing that I want to do is I go onto the website, click on samlabs.com. So this is our homepage, and right away you'll see there's different tabs on the top. So we have what is Sam Labs, what are the products, getting started, teaching materials, and support. So I want to go to the teaching materials, and I see right here, Sam Space lesson plans. So I can look down, I can scroll, and I see we now have a brand new range of age groups. So we now have a progression, not just one size fits all. We really have an age group and progression with different activities from ages 8 to 9, 9 to 10, moving all the way to 10 to 11. So these 11 to 12, these groups are really for progression, so that we can fill the gap between how do I work from my elementary to my middle school, and how do I really progress those students through different activities. So we have different levels and of course different grade levels. So here we have smart doorbell. So in this lesson, students will consider the pros and cons of technology, specifically how is technology benefiting us, or how can it aid us? And this is a fantastic lesson plan that both incorporates science, computing, engineering, design. You can go ahead and click download on the lesson pack, and it will actually download straight into your folder. So this is all in PDF in different formats, and we'll show you what that consists of right now. It unzipped, we unzip the document, we can go in and we can unlock that, and we see three different things. We have the three components of the new lesson plans, which are extremely important. We have the teacher slides, okay? So we can actually present this, whether you have a smart panel on the front of your classroom, whether you have some form of Promethean or something like that, you can project that. If you have a projector, those are the slides that you can use. Next, we have the lesson plans, okay? So the lesson plans we use for the teachers that can actually go through step by step. So if we click on that here, we can see we have warm-up activities, mini lesson, the key information, exactly what we're going to be addressing. So science, a system that can be described in terms of components and their interactions. Engineering design, we're going to be constructing something. We're going to be designing a solution. In terms of computing, I think will be self-evident in when we start to build those different algorithms to make the smart doorbell. And then also ELA. So later on as the lessons progress, you actually start using different text-based in the approach. So using that for the counter. So very first warm-up is looking at the scientific investigation. So how, for instance, technology aids somebody with hearing impairment. So right away, there's a video that you can click and link and start reading about that. And then we have a warm-up on introducing the students, well, can technology be a benefit? And if so, how can we aid potentially people with certain disabilities, etc.? So then we have the third component, which is also the student workbook. So with the student workbooks, we can go ahead and actually fill out the different questions. So these directly connect to the lesson plan. So the next thing we're going to do is we're going to look at the application. So remember, we have three components. We have the lesson plans, we have the blocks, which I showed you, and now we're going to look at the application. So I launched QuickTime, and now you should be able to see my wonderful little iPad. And don't forget, you can run this also on your Chromebook or on your Windows PC. And I'm going to hit in the Sam Labs application. So going into the Sam Labs application, we will see right away a welcome screen, and we see those three components lined up again, the lesson plans, the blocks. But I'm going to go into offline mode, so we don't need the internet potentially, and we don't need to sign in. So the first thing we're going to do is we're going to look at the blocks that we need for the lesson plan. So if we go back to the teacher slides, which we're going to use as our guide, we're going to look at that step-by-step activity. I'm going to build a bit more of a simplified, very quick webinar version, as unfortunately we don't have the full 50 minutes today. So first of all, looking at the lesson, we can watch the video, we can understand, well, here are some of the different ways that we can communicate potentially with somebody who's hearing impaired. But today we're going to build a doorbell for somebody who can visually see that somebody is at the door. We're going to add some sound as well, just in case, because that could also be for somebody who's vision impaired. So looking at the activities, we see right away we need a light sensor and an LED. So I go ahead and I go back into my iPad, and I've got the two blocks. I'm going to drag up the camera so you can see that. So you should be seeing right now the two blocks that I've grabbed from the kit. We have the light sensor and we have the LED. So the first thing that we're going to do is power those on, and that's very simple at the top there. Just power on and we see the lights go on. And right away on the top left-hand side of the application, we see connect blocks. So I'm going to connect the blocks. I go ahead and I click on the light sensor, pairing that. So if you ever connected any headphones, this is much simpler and quicker. Boom, boom. There we go. We're connected. So now the first thing that we might want to do is actually see if the blocks are active. So I drag them up on the screen, and right away in real life, we see that they're connected as well. But how do we pair them together? Well, I simply drag and drop a line. This is how I build my wireless circuit, if you will. I've now produced a connection between an input and an output. Very, very simple. And I'm now going to go ahead and show you what that looks like. The interaction of the light sensor is that variable input, meaning that, oops. One moment, please. Seem to have thrown the block off my table. Okay, so if we see the light sensor right here, if I cover it, actually, we see that there's no light shining. Whereas if I let light shine on it, it will actually turn on the LED. So we see a direct input-output interaction with the blocks from something as basic as connecting here. So if we look back at the lesson plan, however, we see that it's going to ask us to turn this light sensor, which reads how much light there is in a room, into a button. So we can go in here, so changing it from a variable to a Boolean on/off. We go into the settings wheel and we can change that right here. We can drop down on the menu and we can see we can use it as a center, or we can use it as a button. So we can use true, false. So now, instead of sensing all the light in the room that we see here on this wonderful summer day in New York City, instead, we are going to tap on the block, and every time we tap on the block, it either becomes true or false. So it becomes a button, okay? So this is going to be the first piece of our doorbell. I think you need something to push at the front of the door so that that you can notify somebody on the other end. So this is our first component. The other component is, of course, the LED for visual signal. So now when I go ahead and show you that in real life, I go ahead and I'm tapping the block on the ground. You can see that turns on the LED on/off. Right, so looking at the next step in the slides, we can see right away a counter. What's a counter? Well, if we look on the bottom of the application, we can actually see that we have this wonderful thing called software blocks. So we have my iPad commands, and I can scroll from left to right, and I can see a lot of those different blocks. So I'm going to say to myself, okay, there's the counter on the bottom right. Let's connect that. So the way that you connect it is you just simply drag it up and slide it in there. So we now have a connection between a input, which is in this case a button, which will go on and off. So the counter is going to count how many times it goes on and off. Potentially, we want to notify how many people or what type of person is at the door. We could say if I'm getting mail, I would like 2 clicks. And therefore, I know that there's mail at the door. Who doesn't like getting mail? All right, so the next thing we're going to do is consult the next step. We wanted to reset. So I can go and control in the counter when I want that counter to reset. So of course, we want to be able to keep using that doorbell when I push the button twice. We don't just want it to have 2 click and that's it. 1 visitor a day limit, unbelievable. So next thing we're going to do is go down and consult the next slide. Now we need a compare block. Now we're getting technical. So for that algorithm that I told you about before, we're going to use what's called the compare block. The compare block, you simply slide in here, okay? And what we see there in the compare block is an equals 60. Now, what if I actually wanted to change that? I can change that to greater than, less than, or equal to. A compare block is very basically telling me I want this to equal this. So I could say 2, okay? So 1, 2, we made the counter reset at 2. So now if I push the button once, twice, on 2, it turns on the LED. Just so you can see that. It's 1, 2, 1, 2, 1, 2, and it turns off. So it will count how many times I push and then only turn on that LED when it's hitting the right number. So that's a little algorithm that we've just created. Okay, so now imagine if I use my pieces in the kit, in the classroom kit, we have 2 of these. We're going to use these accessories. We're going to say this is our front doorbell piece right here. So when I tap a certain amount of time, somebody's going to let us in. So I'm just going to place that right next to me, hard to see a little bit. And we're going to use this base right here, which is a multi-purpose base and can also be used for car in different vehicles. We're going to put the light signal somewhere here. So at the end, we're going to look how they interact. Now, the other thing that we might want to do is we actually might want to add some sound, even though we're looking at both, we could say vision and hearing impaired, we might want some sound as well. So the way that we would usually do that is we'd scroll back to different apps that we have, such as sound player. I would connect the sound player to this output after the algorithm. And I could say, actually, I want that sound to be a doorbell. We have many different things from music, of course, food, games, but in this case, it's going to be a doorbell. Could be a phone. It could be all these different things that we could use in the project. And that's really the beauty of the application. It allows you to really expand. It's an open app. It allows children really to explore what they're trying to build. They're not just forced to do one thing or another. It's really open-ended and conducive to creativity. Next thing is, because my iPad is currently connected via cable to the laptop, we're not going to have sound from the sound player. So this usually comes directly from the speaker of the device that you're using. In this case, we can't use it. So I'm going to go off the rails a little bit, and I'm going to use a buzzer instead, which we will hear. So I go turn that block on, and I go into my top left, connect my buzzer very simply again. Once that's connected, I simply drag that on as well. So just so you see what the buzzer looks like, this is what the buzzer looks like. There's buzzer. And I've connected that now as well. I'm going to make sure that the button resets. There we go. So we don't have the sound yet. And we connect the buzzer there. So the buzzer is actually going to play us a different sound, okay? Now, if we have a look at the lesson plan, it actually does continue on to discuss numbers and reset. So we use text-based and different applications in order to create that doorbell, but I'm going to defer from that just a little bit for the webinar's sakes because we're on limited schedule. So here, what we have now is we have the number counter, we have the buzzer, maybe we want to make a quick little tune so we know it's the male tune. So we can scroll all the way past on the right to the different songs, music. So we're going to go use a sequencer. And a sequencer actually allows us to make our own song. So once again, like I said, it's a very STEAM-based project. We're looking at all different areas, even though I have, of course, changed it slightly. This is just due to the sound player not working. So here now we have a full setup. We have a smart doorbell designed. We have an input, 1, 2, could be the male person. Then we have the sound of the male song, and then we have the light also turn on. Potentially, in the UK, it's Royal Mail is red, as in very many places. Maybe potentially US will go blue, but the different male colors. And now what we're going to do is we're going to look at that. So let me stop sharing this screen. So now we should be able to see me. One moment. Okay, so now we're back. So what I've gone ahead and done is we have on one side our wonderful doorbell, and on the other side we have our wonderful light. So now potentially if this was outside, of course, of the door, we would then be able to use that completely wireless, so that's no problem. We can do that. So I go 1, 2, and then we see that the light has gone on. We have the male song. We've built a smart doorbell that enables us to see as soon as that's done, we turn it off and the system simply ends, okay? So the next thing that we're gonna do is we're gonna look at the various different lesson plans, but we're also going to look at the new application that we have available, which some of you may not have seen yet, including Blockly, and just go over that briefly. In the new lesson plans, it's really a key focus that all of them align with NGSS, but the Common Core as well, and that is a fantastic new thing to have, of course. Now, if we go into sharing my screen again, the lesson plans themselves under teaching materials are available at the top level. So we have SAM Space lesson plans. Just below that, you also have SAM Space projects. So specifically for summer camp, etc., we have some great project-based learning. For instance, the same lesson plan, along that same line of the lesson plan we just did, we have this project called Super Home. The Super Home is also a design thinking project in which students or summer camp attendees are encouraged to use design thinking steps in design to produce this smart home. So it could be using the various different sensors that you have in the kit to not just address a doorbell, but we could also look at potential temperature sensors. We could look at proximity. So how does it work when I'm walking in the hallway? Do I need lights to turn on? When is a specific temperature? Do I need my heating to go on? Unfortunately, video won't play. We've got some internet issues, it seems. But we have various different things in terms of the project, including building everything from a a cat toy to a Lego ball saw and DIY guitar, which are really fun activities. So I really encourage everyone to take a look at these projects right here as a project-based guide for summer activities also. Now, in terms of Blockly, which we've launched, which is blockly.samlabs.com, we have a whole new offering that is not just a basic getting started here, but we're really looking at that coding element. So when I told you about breaking down decomposition, we're looking at that in a much more block-based version. So we can see connecting your SAM blocks. How do we do that? Starting to code, lesson number 2. Once again, we have this progression, and you're really welcome to explore this as well. And I do encourage you, and do hit me up on email at david@samlabs.com in case you have any questions. Happily answer those. So start programming. We have, first of all, projects that are uploaded from different groups here. And if we want to go into the programming, we look at what we have available. So we have this left panel here, slightly different layout, as you can see, but we have everything from, just checking that I am sharing my screen. Yes, okay, great. We have everything from devices. So general, we have looking at different programs, we have logics, we have loops, we have colors, so mathematics, text, lists, so all these different functions. But in terms of how it interacts differently from the software you just saw, this one would run on the Chrome browser. We can add those same things. So we could say, actually, with the same doorbell, we would add the light sensor, and then we'd add another device. We would add the LED. So all the projects buildable on the Blockly app. Potentially, you could also add them to other devices. Here you can see that we can connect via Bluetooth. I'm going to go ahead and use these two. While I'm not doing an exact run through of the project, I just like to show you very briefly how it interacts. You could say when the light sensor value changes, then we have actions, set the RGB LED color to, for instance, we used blue before, it allows you to use blue. We have different logics and loops that allow us to run the program at a certain amount of time or a specific value. If we wanted it to, we could say when the specific value is set. Here we go. Colors, text, then it would generate and start this program. You can run it right here. So we can also download the projects and share the projects. So if we go into the gallery, I would encourage you to have a look here. We have servo drawbridge, as we've seen different projects. So really encourage you to check that out. And this is a really great new environment for anybody using Chrome or potentially just interested in Blockly as well. This also runs on MacBook and on the Chrome browser. So as an overview, those are the different projects and lesson plans that we now have. I encourage you to check them out. Please do follow up with me if you have more questions on info@samlabs.com. We also have a brand new range of kits in case you haven't seen those before, from the Alpha kit all the way to the Classroom kit. Classroom kit being the full classroom solution. So do check that out as well. And I'm happy to answer any other questions. If you're attending ISTE, let me go to the... If you're attending ISTE next Monday to Wednesday, please do stop by our booth, check us out. We'd love to meet with you. We'd love to chat with you. We'd love to figure out how this potentially fits within your summer plans or how it potentially fits in for your school or system next year. So we kept it nice and spicy and short. I hope that you learned a little bit. If you have any questions, connect with us, and that's it. I hope you enjoyed it. If you want to see more, let me know. Thank you very much.